Hi everyone, I am Akshay SD and I am from Sri Venkateshwara College of Engineering, Bangalore, and I am going to explain about the memory location and address. In this memory location and address I have prepared some slides. I am going to explore that slides. In first slide is introduction to memory location and address. In introduction to memory address, the memory location refers to the specific location and where data stored in a computer's memory, and each memory location is assigned an unqueue address which allows the computer to access and retrieve to stored data. Memory address are represented in binary from casting of series of 0 and 1s. In given a picture, we have seen it the memory location address and operation. I am going to next slide. In next slide, I have prepared some physical memory and RAM. What is physical memory? Physical memory, also known as a random access memory, is the primary storage space in a computer. RAM is divided into small equal sized memory cells, each with a unqueue memory address. The size the size of these memory cells determines the maximum amount of data that can be stored in the computer's memory. I have prepared some the images in a replace with a custom all generated image. In this picture we have seen it the types of primary memories and secondary memories. In primary memories is DRAM, SRAM and DRD RAM. In secondary memories PRAM, EPROM and EEPRAM. In next slide, I'm going to next slide is a virtual memory tagging. Virtual memory is an extension of the physical memory and is used to when the available RAM is efficient. Virtual memory allows the computer use a portion of the hard disk as an extension of the RAM. Tagging is the process of the transferring data between the physical memory and the virtual memory. In the virtual memory, two kinds of address: CPU uses virtual address and main memory physical address. In given picture, we have seen. Next slide. Next slide is a memory hierarchy. Memory refers to the organization and of different types of memory in a computer system. At the top of the is the CPU cache, which is the fastest and closest memory to the process. In hierarchy extend to the different levels of the cache memory and secondary storage devices like hard skills. In computer memory, these are the given picture we have seen. Next slide. Next slide is a memory address and pointers. Memory address has the numerical value that unqueue identify a specific memory location. Points are variables that store memory addresses, allowing programs to access and manipulate the data stored in specific memory locations. Next slide is a memory addressing mode. Memory addressing mode defines how memory addresses are calculated and used in the instructions. Direct addressing modes used in a fixed memory address to the access data, and the indirect addressing modes uses a memory addresses stored in a register of memory location to access data. In given picture, image sources replaces with a custom AI generated image. Next slide, big and little endian. Big endian and a little endian are two different methods of storing multi-byte data in memory. In big endian, the most significant byte is stored at the lowest memory address, and little endian is the largest significant byte is stored at the lowest memory address. Big endian and little endian. Next slide. Next slide is a memory allocation and delocation. Memory allocation is the process of reserving memory for storage. Dynamic memory allocation allows the programs to request and release memory during runtime. Memory delocation is the process of the filling up memory that is no longer needed by a program. In memory allocation, there is two types. One type is static memory allocation and one other type is dynamic memory allocation. I am going to next slide. Next slide is a memory fragmentation. Memory fragmentation refers to the divisions of available memory into small non-contiguous blocks. External fragmentation occurs when free memory is scattered through the address space, making it difficult to allocate the large contiguous blocks. In picture, external fragmentation. In there is a total free memory available allocation. There is a blocks, types of blocks is used. Next slide. Next slide is a summary and key points. In the summary and key points, we have seen that the memory location and address are crucially accept the of computer systems, enabling the data storage and retrieval. Memory addresses are unqueue identifiers associated with each memory location. Different memory addressing modes and techniques are used to efficient access and manage data in memory. Memory location address and operation. We have seen it in the picture. And this is my presentation. I will end the presentation and thank you.